Hi everyone. Let's continue from where we left. So last time we talked about weight groups and anonymous functions and how we can create these coroutines. Now we will talk about these channels. So let's start with what channels are. So basically channels are a way through which multiple coroutines can talk to one another. They can synchronize data. They can one coroutine can send data and other one can receive it. So we can do these types of things. The idea is that we want to communicate between coroutines. Now, why can we not use variables for it? Why only channels? And what is the other, like, what are the other use cases of channels? I think you'll understand it better when we make a basic program. So let's create a new folder called channels. I'll create a separate project for this also. Let me zoom in a little bit. Okay. Should be. Yeah. So how do we create channels? So for that, what we do is we use make and we can simply give chan and then we can give the data type of the like elements that we want to send inside the channel. So for now, let's call it int. So now we can send, for example, I can send int values into this like this. Now, one more thing to remember is this is how we add stuff to channel. Unlike variables and stuff where we use, for example, a is equals to 1, here with channels, we use this thing. So how I like this, how I like to understand this is, let me show you a diagram. So here's a diagram that I have created. Now you will notice that we can only have arrows towards the left. So in Go, you can only create arrows towards the left. Now what happens here is if we want to give channel a value or if we want to add a value inside a channel, this is how we do it. So channel is at the receiving end and we are sending it a value. So think of channel as a box. So now we send one inside the box. What happens is one goes inside the box, right? I think we should rather do it this way. Make it here. Yeah. So we have sent one inside this box now. Now, when we want to receive the value, here in this case we are printing, but we don't have to print. We can also do other things like I can also do A is equals to. So I can also do this thing, whatever, right? So now one is inside the box, and now we are getting one out of the box towards the fmt dot println or towards this a variable. So what this will do is it will either print a, or it will either print one, or either it will assign this value one to a. So this is basically how it works. Now, if we come back to code, I think you will be able to visualize. Here we are giving one value inside the channel. Think of channel as a box. So now one value has gone inside the channel. And now if we do something like a, something like this means that we are sending the value inside the channel. We are giving it to a. Or if we do something like fmt dot println, not one, we'll do channel here. Okay, yeah, that's the mistake I made with a also. With a, it should be something like this. Why am I sending one? You cannot send one, right? You can send the value inside the channel. So value inside the channel will be redirected to this fmt.println, or value inside the channel will be given to a, right? Now let's try to run a few things. Let me remove this. See what's happening here. There's another thing with channels that a channel can only send, or you can only send something inside a channel when you have somebody who's listening to the channel. What I mean by that is you can only send a value to this channel when you have somebody listening to this channel. So you need to have somebody who's listening to the channel. For example, something like we did earlier. Now this FMT is listening, or this print statement is listening, this function is listening to the channel, right? What if we do this? Let me first import FMT. What if we run this? What happens? So this will actually give us a deadlock. It gives us a deadlock. Why? Like I said, we can only send something to a channel when somebody is listening to the channel. So if you think it in terms of pure programming, you'll not be able to understand it. Think of it in terms of concurrency. What I mean is, if we are sending something to the channel, we are receiving it afterwards. I want you to do something that when we are sending something inside the channel, at that time itself, at that exact time itself, there should be somebody listening to the channel. In this case, first this will be executed, then this will be executed, right? So at the time of sending, we do not have a listener. Once sending is done, only then the listener will come, right? So how do we do it? How can we do this? What if we create a go routine here and I put it inside this? Now, if you look, this will happen concurrently. So now we have somebody who's listening to the channel, right? And it is waiting because it is listening to the channel. It will wait. Okay, unless channel has something, we will wait. And concurrently, this will be executed. Concurrently, this will be executed and we will have something sent inside the channel. And now this will say, do we have somebody listening to the channel? And we will realize, yes, we have somebody listening to the channel, right? So now this should work. Let us run it now. Go run main.go and it runs. It says one. What if we exchange this? What if I exchange this? I put it here, the listener, and I put this here. What do you think will happen? At this case, what happens is, see, we have this runs, and then this becomes a go routine. This runs concurrently, and we come here, we put something into the channel, and we know somebody is listening, but nothing will be print because the main execution will be ended. Because the main execution will be ended. Let's try go run main.go. And it does not give us a deadlock, obviously, because we do have a sender and we do have a listener, but it does not print anything because by the time anything would have been printed, main function has been executed completely. So let us bring it back up here and let us bring this here. One more thing I would like to say is that what if I remove this? This will not give an error. This will not print anything, obviously, because we do not have anything to print. We'll have to remove this also, but this will not give us an error. See, this doesn't give us an error. So channels are not only used for communication between goroutines, but also for synchronization between goroutines. We not just give values, like exchange values between goroutines through channels. We also do one more thing. What we are doing here is this is a blocking statement actually. So until or like unless we do not have any value inside the channel, will not proceed. Something like that. This will keep on waiting unless there is a value inside the channel. And when this is executed, this also gets executed and we can move on with life. This diagram will help you understand how these channels are working and how these becomes a blocking statement or how these can receive values between coroutines. So this consider this as a go routine and this one is our main execution. So when the go routine starts working, okay, go routine is working and it gets finished here. But we also have a channel. So somewhere between in the go routine, we are sending some value to the channel. So it is something like we are sending this value to the channel, right? Now that we have a value in a channel, if you look at this point, this is a blocking statement. So what happens is, see, this keeps on executing here and simultaneously this is also executing at the same time here. Now, if it reaches here and this has not reached the channel yet, so we will wait. We will wait until something is put inside the channel. Assume we are waiting here and this starts going, and this puts a value inside the channel. And concurrently, now main function also has something inside the channel. So it will realize that, okay, we've got something inside the channel. So now we can start moving ahead with our main function. So this is basically what happens with channels. It can be used now. You can use this as a you can use this as a blocking statement, or you can use this for receiving value from this channel. Both would work. So this is basically how channels would work. So now let's do one more really basic program so that you can get this like habit or intuition about channels. Let's create one more. Let's call it channels sum. So I will create a channel. I'll create a channel and we can pass int value inside the channel. Let's call it ch. Now let's create a anonymous function with Goroutine. So what should we do? Let us do one thing. Let us create a for loop. Let us say there is something called sum, which is at 0, and we will run it till 10 from 0. I'm talking about I, and we will pass, like we will sum all the numbers from 0 till 10. Let's say I, right? Now we will give this value to, we will give this value to ch. So you have to be careful about this. We are giving the sum to this box called ch. And now we can do out, like we can print this stuff by doing this. So now see this sum we put inside ch. And now whatever there is inside ch, we are giving it to this println function from FMD package. So do you think this will work or not? I think this should work. Let's see. Okay, so we are at the wrong place. And this does work. Let me also do one thing. Let me print the I here. Yeah. So this is how it looks. So if I is correct, I would assume the sum is also correct. What else can we talk about? Yes, we did not talk about this thing. So what if I put one more value to channel? So I'm sending this sum to channel, right? What if I do ch and I'm sending one more thing to channel? What happens then? Let us run and you will see it runs. It runs because we reach here, we put value to it, and it gets executed. So nothing happens with this. So this maybe is not a really good example. Let's go back to our this question, this function, not this, in channels. Yeah. So here, if we add one more thing to channel, what happens? I think this will also be executed because this sends some value. This is waiting. This will be done, and the main function ends. So this should also run. Yeah, this also runs. What if we swap it? What if I do this? Firstly, let me remove this one, and we will rather print it. And we will also add a sleep for 4 seconds. So you will see that this puts in a value and it goes to sleep. And by the time these 4 seconds would happen, before that, the go routine will also be like running and it will receive the value and it will print it. What I want to say is, what if we put two values inside the channel and then we try printing it? What happens then? Let us run and you will see it goes to deadlock. Why is it so? Because we have created something called an unbuffered channel. What is an unbuffered channel? Think of it as a single box. So it is just one box. So if it is just one, like it is just one box with one capacity, we can only put one element into it unless it is removed. So it's like I put one and I remove one, right? So now the box is empty again, right? So I put one into the box, I remove one from the box, box is empty again. So we put two into the box, but there is nobody listening. So now nobody is removing two out of the box. If we go back to this diagram, you will see that we put one into the box and we take out one from the box. So this will basically get removed and this will be assigned here. This was here and it will be assigned here, right? So this is how we work on channels. If we put something inside it, we can remove it, something from it, but we can only put one thing at a time. So this can only have one value, right? What if we do this? What if we move it here? I'll copy this. What if I put one more inside it? So now this is like one. It is trying to put one more inside it. This won't happen. One will be put inside it, one will be removed. Now we have put one again, so it should also be removed. You have to make sure that your Go routine or your channel is not like it's not having a value. It should be empty. By the end of the program, your channel should be empty. That's what we need to make sure. So if it is not empty, it will give us a deadlock. If you put in two values, you have to take out two values somehow. Because like I said, it is a buffered channel, it is an unbuffered channel. Buffered channel is similar, the only thing is different is that we can set a capacity of this channel. Right now it is one capacity only, right? We can only put one thing at a time. With unbuffered channel, if we say value 3, so it can hold three values at that case. We will look into it later. First, let's only talk about unbuffered channel. Then we will do at the later part of the video, we'll talk about buffered channel as well. Let us do one more basic program. So I'll call it PHA channels 2. So in this one, let's create two Go routines. Let's start with a print statement that let's call it start. And then we will create a channel chan and we can put inside int, or let's this time put string. Nice. Then we can create a anonymous function with Goroutines, and we can say that we are inside this Goroutine, and let's say inside first Go routine. And now what we will do is we will put some value to the channel. Let's say we put value called, this is first Go routine, so let's say 1. Now let's create another Go routine. Let's say inside second Go routine. And this time we will take the value that is put inside the channel. We'll call it without any arguments. And this is done. Everything is done. Let's also add a ending statement. So let's say end. What if we run this? Interesting. So we said start, this happens, and it ends because these two are working as go routines. And by the time we would print something, it ended, right? Okay, so let's add a time now again. Let's say 5 seconds. Let's run it again. This time we will get the answer. It is waiting for 5 seconds. After 5 seconds, this will be done. Yes. So what happens here? This is executed first. Nice. Channel is created. This is running concurrently. This is also running concurrently. The first one that executes is this second. So we go inside this, we print this concurrently, and we are also inside this. Now this will put something, this will wait for something to be put inside the channel. So this should be executed then. So this is executed then this is executed, that we are putting one inside the channel, and then this is executed that we have put inside channel one value. Now we are printing that one, so one, and then it ends. After 5 seconds, this will be printed. And if you don't want to use this sleep statement here, then we can also use wait groups here. Like we would do WG, and when we run the first coroutine, we can say WG dot add one, and then we ran the second coroutine, we can say WG add one again. And as soon as this coroutine is done, we'll use defer function here, and we'll say WG dot done. And since it's a closure, it can take this WG without us giving it inside the arguments. So this is done once, this will be done again, and here you can say WG dot wait. I think this should work fine. Let's run it. Time is imported, not used. Let's remove it. And you will see everything works here. Start, then this value is also printed, and then we print. And because why does this work? Because we are waiting for the counter to become 0. So here counter is 1, counter becomes 2. Now once these starts getting executed, first this one will be done. So this is printed first, but then when this is completed, defer function is called. Like I said in the previous video, defer function runs after the function returns, but before the function exits. So this will be done, and then this will be done. Done means we will decrement the counter by 1. So this becomes, it was 1, then 2, then it becomes 1, and then it becomes 0. And only when the counter is 0, we can proceed ahead, and this prints end. Now let's do one more program about unbuffered channel only. And this time we will try to range inside an unbuffered channel where we are sending a lot of elements and then we are receiving a lot of elements. So let's call it range. And what we will do is, first let me do this basic stuff. I'll create a channel. I'll put it like I'll put the int value inside that channel. Then let us create a endless loop, infinite loop. And in that loop, we can say, let's not create an infinite loop. Let's create a loop from 1 till 1000. 1000 I plus plus. And what we will do, we will put this value of I inside the channel. Now that we are putting all the value inside the channel, and you already know that a channel, this is an unbuffered channel, right? Let me also tell you how to make buffered channel. We just have to add value here. We will talk about it later, but we just have to add value here. I'm just giving you some like idea of this earlier. So what I want to say is we can only put one value inside a channel at a time if it is an unbuffered channel. So how are we going to put these many values? we need to we need to bring out values as well. So as soon as one value comes inside this, we need to take it out. So we'll have to do this, something like this, right? So as soon as one value comes in, we have to do this. For second value, do this again, do this again. So we have to make sure that we take out all the values. We take out one value and then we put in another one. We take out one value, then we put in another one. So that's what we will do. Let us create a go routine for that. What are we going to do? We are going to range over all these channel values. So how are we going to do that? We will simply say for I, and we will say range over this channel. Again, we should know we can use channel Y because it's a go routine, and sorry, it's a closure, and in closure we can take values from the surrounding function, from the parent function, which is main in this case. So we can take ch. Now it says I. Give let's print it. Let's print I. Not I. Yes, I. So now what happens? Channel is created. This runs concurrently. Then we are sending one value. So what happens is at this point, we will send I is equals to 0. We will send it inside ch, right? Now we cannot send one more value. So it will wait. Concurrently, we are doing this. So it will print the 0 value from here. Then it will put in another value. Then it will bring out another value. It will put one value, it will bring out another value. Every time you think about channels, you should make sure that you are thinking it in terms of concurrency, not in terms of the regular programming stuff. Only then we will be able to understand channels effectively. Now let's try it. I need to go to range, and this works perfectly fine. I also want to do one more thing. Let us keep it short. Let us keep it till 100. And as soon as we print something, I want to have some sleep time so that we can see how the things are working. So let's call it 500, not micro, milliseconds. You will notice it will always run in a particular order, right? It will always run in a particular order. If you remember about Go routines, then they do not run in a particular order, right? So that's also one very important thing. Like I told you already, channels are also a way to synchronize. Why are they running in a particular order? Because if you see, I put in one inside the zero inside the channel, and then zero is taken out. Then I put one inside the channel, then one is taken out, two inside the channel, two is taken out, three inside the channel, three is taken out. So it will regularly print one element at a time. So it ran completely till 99. So I hope you were able to understand this. Now I think we can talk about buffer channels. So let's create another project called buffered main.go. So how do buffer channels work? I've already given you some idea. So what we do is we say make chan int, and then we can say the size of buffer channel. We can call it 3. So now we can have 3 elements inside the buffer channel. What I mean by that is I can do this. I can put in 1, I can put in 2, and I can put in 3 here. And now when I create a we can create a go routine. We can say ch, we can say let us print, and we can print it once. So we have taken out one value from the buffer channel, two values from the buffer channel, and three values from the buffer channel. So earlier, what would happen was we cannot put in three values firstly, right? we are continuously putting in three values. It would not work earlier, but it will now work because we have a size of three, right? So this will not block it. So earlier, when we used to have a unbuffered channel, this would have not worked. Let us run it. Let me first go to this buffered, and then now let us run this. So it gives us deadlock. Why? Because we are trying to put stuff inside it. We are putting one first, and then we are putting two, but it can only put one. If this one is somehow removed, like if this go routine was above, and somehow we can create a program where we first enter one and then remove one and then enter two, remove two, enter three, remove three, that would work. But since we are not doing that, it is not working. But after I say three here, this basically means you can put in three values because the size is three, right? So we can put three elements inside that box. If we keep it two, we can only put two elements inside the box. So now I put one and I put two. So to put three, the third value, I need to first remove one value, which we are not doing here. So it gives us an error. But if I say three, then we are putting all three values inside it, and then we are bringing out all three values from it. So what will it give us? It runs, but it does not give us anything, obviously. Again, we need to make a wait group. Add one. As soon as this is done, we'll say defer. We'll say wg.wait. I think this should work now. Yeah. So it gives us 1, 2, and 3. It prints all these values. So this is basically how the buffer channels work. There are a lot more things to talk about. We have to talk about select statements, then we have to talk about mutex. So I think we can have that in a separate video. We have not covered buffer channel completely, so we will also look into how we can range over buffer channel and all those things. But we have already covered quite a few things in this video, so maybe we can keep that for another video. I hope you were able to understand everything about the unbuffered channel that we talked about in this video. I hope this video was useful, and I'll see you in the next one.